Hi, I'm Paul from Velo, and as usual, it's wheel building day here in the workshop. A customer has requested a lovely set of gravel wheels to be hand built by me. He's seen our videos, I believe, so that's how he got hold of us, and he'd asked if we could document the process. So we've done a lot of wheel building videos, but in this one, we're going to document the process of me building the wheels. And then I'll also talk to you about each stage of what I do when I build a wheel, also what tools I use and what specification the wheels are going to be. Come join me. So we're using the DT Swiss G540 rim, a really great go-to gravel rim, super strong, rated up to 130 kilograms total system weight. So that's the rider, the bike and all the luggage. So a really good choice for gravel riding, bike packing adventures and most things really. Nice 24mm internal width, so good suited, ready, probably like 32 upwards up to kind of like 50C tires. The 650B ones can take a wider tire. This one is the 700C. Now, a lot of people with their gravel wheels do want a nice quiet hub, and this is where the R7070 Shimano 105 hubs come in. Thing is, if you're out on a nice adventure and you've got it's not ideal really. I know it has its place definitely, but these are a really good choice. They come with 32 hole and 32 hole. You can get 36, but that doesn't suit the rim because they're only 32 hole. So really nice solid hub, center lock attachments, and up to 11 speed road free hub. So that is the hubs that we're going to use. We're going to use our favorite spoke, the DT Swiss Competition double butted spokes. So super strong. They are 2mm here, 2mm here, and they go down to 1.8mm in the middle. So they can just take impact a lot better because of their design. On this one, we've got 290mm on the front. That's the length of the spokes, and 290 on the left side and 288 on the right side or drive side. Bring these together using DT Swiss's ProLock brass nipples, 12mm. So these are really nice. They've got thread lock inside them, so once the wheel is all in its position, it all locks nicely and stops the spokes undoing. Also with the process I'm going to go through, that helps as well. Also, these don't compromise retruing, so you can just retrue as normal. So yeah, these are our go-to nipple, and they are brass. We tend not to use alloy nipples, just brass ones, because they're much stronger and more durable for the British climate. So tool-wise, what do I need? To get started, I need my nipple holder. As mentioned on previous videos, my favorite tool. DT Swiss spoke wrench, my good go-to spoke wrench, and my Park Tool wheel truing stand. And then finishing off the wheel, I use gauges for lateral and radial measurements. Then I will fit some nice DT Swiss tubeless rim tape to finish. So let's go and get on building. So first of all, lacing. So I always start generally away from the disc. I'll do some counting. And what's super important is that logos line up. I went on a ride recently and I kind of an Audax, and I did see someone's wheels and the logos weren't lined up. And I almost cried, I'll be honest, because it takes 2 seconds to do. So if Sarah can get this on the video. So what we have is we've got the valve hole here, and then we've got the O of the 105 there. Now, whether this comes up right, I'm not sure, but if you look through the valve hole, you should be able to see. Oh, there we go, we got it. So super important just to get that right. It's a little detail, it's not the end of the world, but I mean, that what took me 20 seconds. So best to start as you mean to go on, I think. And I'm going to do a free cross pattern. So that means that each spoke crosses the other 3 times. So let's go. So I'm just finishing lacing the non-disc side. So they're taking the longer spoke. You can see here, especially on this side, that one spoke here crosses 1, 2, 3. So that's what I talk about when I'm talking about free cross. You get 2 cross, which we do on 24 hole or 24 spoke wheels, 24 hole hubs. And then you do get 1 cross, which we don't really do. And you do get radial lacing, which is no cross. So basically it goes from the hole up to the rim. We do quite a lot of them for rim brakes. You would never have a radially laced wheel for disc brakes because of the braking power here. It would just go and that would be the end of the wheel and maybe the end of you as well. So I'm going to finish this off and then we'll go to the next process. And as I'll go along, I'll introduce a couple of other tools that I'm going to use along the way. So wheels have been laced. Next stage is to put a little bit of tension in the wheel and then go through some other processes. The park tool stand is set up for a standard quick release. The mount's just up here. So I need to have for this axle, it's a 12mm through axle. So I have a 12mm through axle adapter. Now, what I need to do is get all of the spokes to a nice level start. So if I start tightening them up individually with a spoke key, they're all going to be a little bit all over the place. So what we do to get started is a nice drill bit. This is from Junior, which basically pushes out as the nipple is driven in and the spoke is driven out. So it's really nice. It basically means that we can start with all of our spokes in the same place. So I've used the drill bit. Every spoke and nipple is relatively in the same place, which is nice. I need to just put a little bit more tension through the spokes and then I can move on to the next step. So the spokes have got a bit more tension in them. A really important process is to use a punch and a hammer on the spoke heads because these are classic J-bend spokes. And it's highly likely that they're not in exactly the perfect position. So what we want to do at this stage, once there's a little bit of tension, is use a hammer and a punch on the spoke heads, specially designed for it so it's concave, and make sure we knock them into place. Let's go. So the process now is we want to go through a range of different procedures to get this wheel so it's 0.2mm laterally true and 0.5mm radially true within those parameters. What we need to do is we need to get the perfect amount of spoke tension. These rims, the maximum spoke tension is 1,200 Newton or 120 kilograms of force. So we're going to go just below that to make sure it's not exceeding the manufacturer's specifications and making sure that the spokes are nice and tight. We need to make sure the dish is true, which is spot on, which I'm going to talk about in a second. And we need to make sure that it's nice and true and also pre-stressed. So the dish, people say, they get dish sometimes confused because they'll be like, I need the wheel dished, but they actually mean they need it trued. What dishing is the center of the rim needs to be central over the hub, because if you go to put the wheel into a bike and it's not, it's going to be off in the frame. Some frames require wheels to be dished, say 2mm out or 4mm out to cope with the design of the frame. But traditionally, you have to get the dish right, which is central, and that's super important. And that's why we use a wheel dishing tool. And it basically sits on top of the wheel and you use this gauge up and down to make sure it's in line. So we're going to do that as we go along. Nice little bit of wood here, which you'll see me pre-stressing the wheel. Basically, every time I tighten a spoke, the spoke's going to turn, things are going to kind of knot up. So what I want to do is I want to push on the wheel to basically release that. And as you do that, it will go ting, 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 because I want to do that pre-stressing. I don't want the customer to do that. So they get on their bike and it goes ting, 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 and everything loosens and falls to the wrong position. So you'll see me pre-stressing the wheel, and then I'll be doing bits of truing as I go along, and it's basically little bit, little bit, little bit. And the more you do, almost the less you do, the better it is, if that makes sense. If you go and just gun and do loads of turns on each nipple, you're going to have a lot of work to do later on, sometimes to undo your work, or you've done too much, or the wheel's under too much tension, or it's not dished properly. So I'll go through little by little, and then it should be perfect. Spoke tensiometer is really important, in my opinion. It's not a basic tensiometer, it's really nice. There's more advanced ones. I get on really well with the Park Tool one. Some people will build wheels without using one. I think this is just a good reference. I can feel through the wheel that the spoke tension is correct as I do it when it gets to that point, but it's good just to have this as a reference. And what you do is you put it on the spoke like this. So at the moment it's reading 6. I want to get that up to about 21, 22 on the disc side. With wheels, you measure the tension on the disc side or the drive side on the rear. With rim brake on the front, you measure all of the spokes. And I'm not doing the thicker part of the spoke, I'm looking at the deflection reading in the middle. So we've got quite a way to go, but that's going to be used throughout the process. So again, super important, less is more in terms of wheel bearing. So I started, I think, doing 2 turns per time on each spoke. Now I'm down to half, just so I don't overdo it, and I build tension in the wheel nice and slowly. It means that if there's any truing to be done, it's much easier to sort out, and just means the wheel becomes nicely balanced. So here, as mentioned, I'm pre-stressing the wheel, making sure all the spokes go into the right place. And I can put, at this point, all my weight on here, just to make sure the spokes aren't caught up. There we go, here a little click. So I want the radial movement in the wheel to be between these 2 notches. So it's come up really good. There's always a little jump where the rim joins itself. So happy with that. Now on to check the lateral movement. So we're also good to go on this bit. So the wheel's now in the parameters that we want. It's dished correctly. It's within 0.2 mil laterally and 0.5 mil radially. So it's really good, ready to go for the customer. Just need to fit some rim tape, box the wheels up, that wheel up, and then get on and build the rear. So thanks so much for watching the video. I'm just finishing off the rear wheel, going to box them up and then get them posted. I hope this customer is going to really enjoy these wheels. I've really enjoyed building them and showing you a little bit more about the processes that we use when we build wheels. I love building wheels. If you watch our channel regularly, you'll know how much I love it. I love everything about it, building the end product, the whole process. Yeah, and I'm lucky that I build so many wheels. It's great. It's always really important to think about, like, what do you want from your wheels, and hand-built wheels are a really good option if you've got the budget. They're not super expensive, they don't have to be, but they're really good option for you. and something to think about, because it will make your riding much nicer. You can always visit our website if you want to have a look at all the wheels we offer, or contact us if you've got a specific build in mind. Again, thanks for watching, and please subscribe.